Okay, what we have here is a model of the left ear. I brought a skull here for comparison. I'm going to remove the skull cap for you. And when I do so, I'd like to tilt in here and show you the temporal bone, particularly the petrous portion of the temporal bone, which is carved out and contains the apparatus for hearing and balance both. And what we're seeing here in the skull model is represented here in our ear model. Well, let's look at the ear. So we're in the temporal bone. This is called the petrous portion. It's the hardest bone of the body. Let's start with the outer ear, then look at the middle ear, and then the inner ear. The outer ear is familiar to us. It's called the auricle or the pinna, and it contains elastic cartilage, which is why you can bend your ear and it won't break. It has a helix and a lobule, and it has anteriorly, not shown, but there is a little flap of cartilage right there called the tragus. This is the external auditory meatus. It ends in a dead end, and that dead end is formed by the tympanic membrane or the eardrum. And there are also wax glands that empty into the external auditory meatus. What I want to do is dissect away, if you will, the petrous portion of the temporal bone just by removing this part of the model. And now we can look into the middle ear, which is air-filled, and then the inner ear where the receptors for hearing and balance are all located. Let's just study for a minute the tiny but very important middle ear. It's on the medial side of the tympanic membrane or eardrum. It's air-filled, and it communicates to the nasal cavity via the eustachian tube or auditory tube, the newer terminology. Now right now, unless your ears are in the middle of a pop, this eustachian tube or auditory tube, as it's also called, is closed. It's collapsed. And what it functions to do is to enable air pressure to be equal on either side of the tympanic membrane, which is necessary for its optimum function, and also it's very uncomfortable when the pressure is unequal on either side. But let's first imagine the pop that happens as you go up a high building, like the Sears Tower or say up Pikes Peak. The air pressure around you falls, and as it does so, the pressure here trapped in the tympanic membrane because of the collapsed eustachian tube, that pressure becomes higher than the pressure around, and the pop occurs at the top of the building or Pikes Peak or wherever as air moves from its high pressure to low pressure, equalizing with the lower pressure outside, and you hear that as a pop. Oppositely, when you come back down, now the pressure around you gets higher and higher, but again, the eustachian tube is normally collapsed, but the pressure, because of the previous pop, it's still fairly low here. As you come down, the eustachian tube will pop open, allowing air back in and equalizing the pressure, again, on both sides of the eustachian tube. Now, the downside of the eustachian tube, or auditory tube, is that because it connects with the nasal cavity, a head cold, a nose cold, in other words, a viral infection, may lead to a bacterial infection, and that bacterial infection can, in fact, travel up the eustachian tube and cause a middle ear infection, the most common kind of infection that children get. But that's just an aside, because really we're interested in how the ear works and the anatomy here. My real focus is to show you the function of the middle ear, and to do so I'm going to remove the tympanic membrane and point out to you the malleus, the incus, and the stapes, the three ear bones. The two pairs of them, left and right ear, form the six smallest bones of the body. Here we have the first bone in line, the malleus, which is named well because the name means mallet. It transmits vibrations to the incus, whose name means anvil in Latin, and then the incus transmits vibrations to the stapes. The stapes means stirrup, and it's well named. The stapes vibrates against the oval window And it's sort of like, you can imagine it like looking into an aquarium. On one side there's air, the other side there's fluid. The function of these three bones, they in effect strengthen the vibratory force so that we have a strong force vibrating against the oval window, because here we're vibrating against fluid. It's harder to vibrate fluid than it is to vibrate air. So we have a wide tympanic membrane, and then we have three ear ossicles, or ear bones, that focus the strength of the vibration onto the oval window in the inner ear. Here we are in the inner ear, fluid-filled, and the organ of hearing is found right here. It's called the cochlea, and you can see exiting from the cochlea is the thick 8th cranial nerve called the vestibulocochlear nerve. The cochlear branch to the cochlea takes sensory information regarding hearing to the brain. Let me pick this up for you for just a minute. The cochlea means snail shell, and it actually turns 2 1/4 turns. When I open it up, I can't really see what's in it, but microscopic hair cells, very delicate, are located here, and they respond to the various sounds by vibrating, in fact, which causes them to undergo potentials that are transduced into action potentials on this cochlear branch of the vestibular cochlear nerve, and that's ultimately how we hear.